All right, Mr. Ahmed here for 5.1. 5.1 is going to start the process of solving systems of equations. All right, so these systems of equations, these are going to be a little bit tougher. Definitely going to be a bit more time. They're harder to solve. And we are going to solve these systems of linear equations. And technically, those are going to have two variables. All right, so there's going to be an equation that has two variables, and then there'll be another equation that has two variables. We are going to find the solution that makes both of the equations true at the same time. So our solution is going to be an ordered pair, and it's going to satisfy both equations. Now these first two examples, all right, we're going to do these first two examples, and then we're going to solve a bunch of these, and then we're going to see one of these and be like, I don't know how to do that one. All right, so hopefully put a star by it. Checking solutions, this is the easiest part of this chapter. And it just says, tell whether the ordered pair is a solution of the system. So we are going to see, is the point 1, negative 2 a solution to both equations? All right, so keep in mind, ordered pair comes in the form x, y. We have to substitute in x and substitute y and see if it's true. So I'm going to do the top equation in black, and I'm going to do the bottom equation in orange. And we're going to see whether it's true. So for the first one, I have to use parentheses where I substitute in. So I have 2 times x, which is 1, plus y, which is negative 2. That has to equal 0. Is that true? Let's see here. 2 times 1 is 2. 2 plus negative 2 is 0. 0 equals 0 is true. Check it off. That one is true. Now we're going to check the orange one. So negative, parentheses, 1 plus 2 times y. Y is negative 2. And that's equal to 5. Let's see if that's true. Negative times 1 is negative 1 plus, order of operations, we have to multiply. 2 times negative 2 is negative 4 equals 5. So I get negative 5 equals 5. That is not true. So it is not a solution. The ordered pair has to be true for both. Okay, so now we're going to try the next one. Same process. I'm going to do the bottom one in orange. I'll do the top one in black. We'll see if it's true. X, Y. All right, so Y is 4. So 4 equals 3 times X. X is 1 plus 1. 3 times 1 is 3. And 3 plus 1 is 4. 4 equals 4. That checks off. That one's true. All right, let's try the other equation. The other equation, 4 equals negative parentheses, x is 1 plus 5. Negative 1 plus 5 is 4. 4 equals 4. That is true as well. So this one is a solution to the system. It made both equations true. Okay, so our first method to solving is the least desirable. It's the least accurate, but it's very good visual representation of what's going on. Keep in mind that anytime we graph a line, that line represents every single solution to that equation. So I am going to graph both lines. My solutions to the top line will be in orange, and my solutions to the bottom line will be in black. Where they intersect, that is my solution. That intersection point is where both equations are true because they're touching the same exact spot. So we're going to use slope-intercept form for our graph. For the top line, m is equal to 2 over 1. B is equal to 0. There's no 0. So our y-intercept is 0. Our slope is 2. So I have to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Up 2, right 1. Remember when we graphed, I didn't make as many points. The reason why I'm making all these points is so it's easier for me to see where it intersects. Now, I always said we're always going to move to the right. Now, as I see this whole entire lines going, I should be able to tell that it has to continue down this way. So I'm going to go the opposite direction as well to extend the line by going down 2, left 1, down 2, left 1. Now, if you're going left to right, it's still up 2 over 1, up 2 over 1. So we're following the same pattern, okay? and we're going to fill in the entire graph for this process. After I'm done, take out my straight edge to draw in my line. And our first line is graphed. So I used my ruler. The next line, m is equal to -1/1, and b is equal to 6. So plot the y-intercept first, up 6. And now my slope is negative, so I go down 1, right 1. Down 1, right 1. There's my intersection. I'm going to go one more just to make it super clear. So my intersection point is the point 2, 1, 2, 3, 4. 2, 4 is our solution. We are going to check our work. I'm going to take out my straight edge to draw the other line. We have to be super neat when we're solving the systems by graphing. Okay? Have to be super, super careful with our lines or else we might intersect at the wrong point. That's why I drew in every single point. Now, checking our work, we're going to see if it's true. I'm not going to do this every time, but I'm going to do it this one. So for the top equation, 4, that's in orange, equals 2 times x is 2. That is true. 4 equals 4. The bottom equation, 4n for y, negative parentheses x is 2, plus 6. Negative 2 plus 6 is 4. That is also true. So we got it correct. Okay? So the intersection is the solution to the system. On to our next example. So for these graphs, it's always going to be easiest to graph these in slope-intercept form. So I'm going to isolate y for all of them. So for my top one, to isolate y, I have to subtract x from both sides, minus x, minus x. So y is equal to negative x plus 1. Got the top equation. For the bottom equation, I'm going to subtract 2x from both sides. And we get y equals negative 2x plus 4. So, time to start our graphing process. M equals negative 2 over 1. B is equal to 4. I'm graphing that one first. So up 4, down 2, right 1, down 2, right 1, down 2, right 1. Okay, follow that whole pattern across the entire graph. We have to fill in the whole thing for this process. So I'd have to go up 2 and left 1 to follow that pattern. All right, first line is complete. Taking out my straight edge, drawing it in as neatly as I possibly can. There we go. Okay, orange line. M is equal to negative 1 over 1. And B is equal to 1. So slope is, y-intercept is up 1. And our slope is down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. There it is. We see where it intersects, right here. Our intersection point is 3, negative 2. We have found the solution to the system. I'm not going to plug that one back in to check the work. Just going to fill in my line. You can plug them back in to double check, just like we did at first. Actually, I will do this one. I changed my mind. We'll do this one. We won't do the next. So when I plug it back in, the top equation, 3 plus negative 2 equals 1. 3 plus negative 2, that is 1. That's a check. Bottom equation. X is going to get plugged in. So 2 times 3 plus negative 2 equals 4. Let's see if that's true. 2 times 3 is 6 plus negative 2 equals 4. 6 plus negative 2, there's 4. That one works out as well. So we got it correct for both the top equation and the bottom one. Our solution to the system is the point 3, x is 3, y is negative 2. Okay? Last one here. All right, top line again. We'll do that one in orange. Y is already isolated. So identify our slope and our y-intercept. Our slope, m equals negative 1. B is equal to 6. Plot this point 6. Down one, right one, down one, right one. Fill in the whole graph for these ones. We need to know where it intersects. Okay, take out my straight edge. Draw a nice straight line. And we'll graph the second line. So, our second line, m is equal to -1/2. b is equal to 5. Plot the y-intercept up 5. And we're going down 1, right 2. Oh, there's the intersection. Down 1, right 2. So our intersection is at the point 2, 4. Found our solution. We are done. I am going to take out my straight edge to fill in that line. And that will leave us with the end of our notes. So, in summary, as you are working on these graphing problems, make sure you are super neat and draw your lines super straight, plot in a bunch of points, and don't forget how to do the first examples. Tell whether it's a solution, just have to plug it in. See if it's true. Has to be true for both equations. Have a great rest of the day.